So I'm wearing my project shirt today. The project that implemented Versity software is called Banksia. So you'll hear me use Australian terms. So let me just take this out. So I thought I'd introduce my center, the Pawsey Supercomputing Center, and talk a bit about Versity products that we use and how that's progressing. So let me just jump straight in. I'm team lead. I'm the senior storage system administrator, and I look after the colder side of data. And I came from GPFS background, and then also running DMF and CXFS. So just a little bit of an overview. This is the environment we have at the Pawsey Centre here in Perth, Western Australia, on the west coast of Australia. So we have different clusters of compute. We provide most of the HPC core hours for Australian researchers in Australia, but also international projects. We have a very large tape system, and we also have a very large Ceph object store called Acacia. So our new system is called Cytonix. It's a Cray Shasta system, HP Shasta, and it's about 50 petaflops. So this is the main HPC that our center provides for Australian researchers. And Cytonix is the Latin name for clocker. So that's why we have a friendly clocker in view. So I might just talk about the Banksia project. So we're going back a few years back. During COVID days, we decided on a number of project deliverables, and you can read them yourself there. So we needed affordability. We were on DMF6, and we had aging CXFS file systems, and we also had aging servers, so PDMOs, etc. We also were looking for, in this project, to have a scalable and expandable option. We needed S3 interface. That's what researchers were crying out for. They said, we need to be able to access our data from anywhere. REST API, so modern tooling. We also wanted open tape format. We didn't want to be locked in to DMF format. And of course, subscription licensing, and also the data migration piece. So if we had to run two systems side by side, our hardware was over 10 years old, and we just couldn't afford to run the licensing further. So we had to cut over. And so that part is very important as a migration. So this is what Banksia looks like. We've gone from 13 SGID racks down to 2 racks, providing 5.7 PB of Scout file system cache. That fronts the 2 existing SpectraLogic tape libraries. So I've put the little diagram up there. You can see of how the system is configured. We might be able to share this slide, so you don't worry too much about reading all the details, but basically you can see we've got 2 SpectraLogic tape libraries with 32 tape drives. It's got 100 PB capacity on each library. They're co-located in the same facility. Because it's research data, we don't have one offsite. And let's go ahead and check. So this is the project stages. This took about 18 months to go through each of these stages. It was very, very important for us to, when we were implementing the winning tender, which was Scout AM and Scout FS, we had to do a lot of testing, and we also had to integrate Mediaflux, which is an architected product, and we needed to involve our users. So we had early adopter testing. We had to migrate fiber for the libraries over to the new racks, and then we have to do verification. So fortunately for us, most of the files we have for our data projects are checksummed. So we took a sample of about 200,000 files and checksummed a lot of it. So it's not a small thing. So the next point is, so I think people would like to know, what the archive is. Oops. some how it's used, etc. We'll go into details about this, and just let's see them. So this is the topology. Again, this is a bit of more of a finer level detail. So you can see we have an FC SAN fabric connected to 6 Scout nodes. We have some DDN arrays providing the Scout file system, and then the fiber channel connection to the tape libraries. Everything's on 100 gigabit Ethernet, and this is important because we want to move data quickly around our center. And this is key for any ingress or egress of data. It's made available on 100 gig, multiple links, so uplinks into the center. So how's it used? Well, this is the key. What's the archive for? So it provides data storage for 2 major Australian scientific data services. One is the Murchison Wildfield Array Virtual Observatory. This is a precursor to the Square Kilometre Array project, and we have held data in this project in DMF since 2012, but in other forms, we held data going back to 2008. So it's over 20 years of research data for radio astronomy precursor. It is, I believe, the largest publicly accessible research data set in Australia. So anybody can go and obtain observations through the ASVO web portal. There's no restriction. It's used internationally, especially if you want to look at observations from the Southern Hemisphere. It also contains examples of fast radio bursts, which are an interesting new phenomenon that is still being researched to find out and describe it. So a lot of the MWA work was done to catalogue the southern skies and the phenomena that they can observe in the skies. The other project is Mediaflux data portal projects. So this is slightly smaller, it's 13 PB, and it contains over 60 data projects ranging from marine science to, we have some Copernicus data. We also have a large number of surveys from biological research organisations, but we mostly focused in West Australia on marine diversity because we have a large coastline. So there's some very important national projects in the data portal. And we used to hold data for another precursor for the Square Kilometre Array called CASDA, but they've moved their data to Acacia and to Luster. We used to be basically an additional 3 petabytes of storage because their processing didn't normally keep up with the ingest rate. So they used to cause a lot of churn in DMF, and since then we've moved them over to our alternate object store, but they've not given up their allocation because they may in the future come back and use tape because they're still fighting that challenge of processing in a timely fashion. So this is a very detailed slide which will give you an overview of the MWA ASVO project. So the part that you can see up here in orange is what we store, all the data on tape for that project. So it's a front end. If you just Google search for a MWA ASVO, you'll be able to see the web front end. And then behind the scenes, this project uses Boto 3, and it also uses the Scout AM bulk stages through the REST API. It also has Kafka notifications so that when the bulk stages are completed for an observation set, which could be hundreds of thousands of files, their broker service, which sits in AWS, listens for that, and checks the message bus, and then provides the full set of files to the end user. So I'll mention this a little bit in further detail. So this is the other project, which is the data portal. And as you can see, it's got a simple GUI, but we've also built a command line interface for this, which is very useful for running with, we use Slurm on our HPC clusters. And we customized the web GUI, but we also paid for the development work. So Mediaflux can now use the SCAD-AM REST API. So that it's always supported DMF, but we needed to use the REST API from Versity, and that's been very good. It's reliable, it's solid. Users didn't see any difference with their content source, so that was perfect for our implementation. So, right. So some getting to the nitty-gritty. So administration and operating Banksia. These are lots of questions that I get asked because we were, involved with migrating from DMF. We had a dedicated team running the DMF and CXFS file system for the HSM. And people ask, is it easy or hard to operate? How many people does it take, et cetera, et cetera. So pretty much, yes, it was easy. It was easy. It is easy to operate. It was designed to need less staff. We've taken the velocity out of the HSM. This is what researchers told us through extensive surveying, that they wanted less churn. But we also scaled, this is scalable, and it delivers millions of files in a single operation, which is what the ASVO folks required. But it only takes about 1.5 people to operate this system. Previously, it took 3.5. So yes, it does need some further enhancements and some more tooling. And like I said, when I ask the Versity team, they usually say yes. They're very responsive. So, like I got tired of asking for enhancements for DMF6, and I was told, look, you just have to go to 7 first. But the dollars didn't really make sense. And I find that if I want a feature enhancement, I'll usually get it quite quickly, within sometimes within a month. Others might be a little bit longer, like a few more months, or some things are still in the pipeline. But that's a lot. It's a difference, between the Versity folks and others that I've worked with. Yeah, and I guess before I finish up, so we need to get into a couple of issues where we get some, because we're running very old tapes, going back 2012, we have to replace those failing tapes. So we have to replicate what was held on those tape volumes. And we have a large number of DMF read-only tape volumes to sparse. So we've got about, I think, 3,500 tape files in each library to sparse. And we actually had to do some extra work to support the Versity solution. So we decided that we wanted to run Keycloak for our service account users. And as you can read there, we put in Kafka, and this is to support the bulk stages for the virtual observatory. We also got asked and had received enhancements to allow us to use Grafana dashboards. And we went through many, many iterations of tuning the parser for DMF. And we also had challenges with Boto 3. So with the S3 gateway, Boto 3 is not particularly good at failing if it fails to upload all its multi-part parts. So I spoke with the Versity team and support, and we basically got the gateway updated. So now everybody has some better behavior through the open source gateway for handling Boto 3 in Python. So yeah, we kind of find all sorts of fun things that the researchers like to throw at us. So summary, lessons learned. Yeah, so as you can see there, the journey to REST API object, etc., is not for the unprepared. So yes, check some of your data. It is very, very valuable, especially if you are doing a very large migration. We had to migrate more than nearly 60 PB of petabytes of data, and checksuming helped us. So it's not without needing to train, just like anything. We did extensive user training, and I think that really helped us. So we had VMs put together. We showed our operations teams and clients how to use the product, and that helped immensely them understanding, because they came from a file system client type and DMF command environment, and so we had to map that across, if you like. Design and peer review and work with a good integrator. So we work with Xenon in Australia, so I'm wearing their logo. They were excellent. They helped us a lot, but we had to spend a lot of time defining what we wanted in terms of performance, data reliability, and they so Xenon and Versity delivered that in our project. And yeah, future work is get the FERs lined up and work together for functions and improvements. And let me just go back forwards. And yeah, even more, feel free to contact me. I'm happy to talk about our experience over the last 3 years. It's been very positive. I have a very light touch, generally easy to manage environment. I'm able to attract new staff who want to work on cutting edge software with really great interfaces, and I can't speak highly enough of the Gateway project too. So the open source Gateway is a fantastic option, and I think it will it's helping a lot of organizations who, like us, we're taxpayer funded. We don't have a lot of money to throw out there on licensing, and I think the Gateway's been a really good success story as well. And recently we've been working in Nate's helped us a lot with some of the functions we've asked for, which is Glacier support. So this is a great way to online files that appear offline, and so it helps augment the use of the REST API interface. So it makes it simpler. So that's it. Likes to go back. I've mentioned Acacia. That's our other object storage, and this is basically the next phase is also we're looking at tiering between Acacia and Banksia. It's something Acacia's filling up quite dramatically, and now we're starting to ingest back into Banksia. So it's not cold, it's starting to take petabytes of data as well. So each week we're doing about 700 terabytes of data ingest. So Banksia is great, but it's getting full. So that's why we can work with both of these services to provide resources for radio astronomy and other research projects. And that's it.